Okay, so in this video, I'm going to be solving this rational equation to demonstrate my knowledge of the concepts we did. Now, I do want to note that the method you showed us, I know how to do it, and I think it's a great method, but I just thought I could make a few modifications to it so that I could solve the question quicker because I thought it'd be useful for a test. So I'll go over the method I used. It's very similar to the method you showed us, just I modified it a little bit. So I'll include the steps on the slideshow, but I'll just explain them verbally here. So first thing I'm going to do is I'm going to factor anything that can be factored. So this x squared minus 4x minus 5, that just factors to x minus 5x plus 1. So x minus 5, x plus 1, and this over here factors to x minus 5 times x minus 2. So x minus 5, x minus 2. Okay, so now we factored everything that can be factored. So next thing I'm going to do is I'm going to state the restrictions. So we get that by setting the denominators equal to 0. So the restrictions are going to be, RES for short, x can't equal 5, x can't equal negative 1, and x can't equal 2, positive 2. So these are my restrictions for this equation. And now here's where I modified it a little bit. So what we're going to do now is we're going to find the lowest common denominator. Now what we do is we just multiply the denominators together, but notice how the x minus 5 appears in both terms. And since it appears in both terms, we don't have to actually multiply the x minus 5s by each other, because then we would do the doubly distributive property and that would get complex. Basically, what I learned is if one factor appears more than once, you just have to write that once in the lowest common denominator. So if we multiply the x plus 1 and x minus 2, and we just pretty much get all the factors from the denominators, our lowest common denominator is going to be, this is our lowest common denominator. So now what we're going to do is I'm going to multiply all these terms by this lowest common denominator. And the point of doing that is to get rid of the denominators, and then I'll just solve for the variable x. So that's going to look like this. So, okay, so now it's very simple. We just have to get rid of the denominators. So we can just cancel the x minus 5 out here. We can cancel the x plus 1. And now we're just left with this equation up here, x minus 2 times 3x plus 1. So there you go, this times that. And now here we can cancel out the x minus 5 and the x minus 2. And now we're left with x plus 1 times x minus 3. And now we can just solve for x. So we're going to do the doubly distributive property here. And now that we have this equation here, we're going to just, we're going to factor it. 2x minus 1 times x minus 1 equals 0. And now we can just solve for our x values. So this is going to equal 1 over 2. And this is going to equal just 1, x equals 1. Yeah, so these are the answers. Now, important to note here, after you find your x values, make sure that they don't equal the restrictions, because if any of them do, they can count as answers. But luckily, 1 over 2 and 1 are not part of our restrictions. So these are two potential answers. Now, with the good thing about rational equations is you can always check your answer to see if you're correct. So basically what you can do is you can plug in your x values that you get into your equations, and if you get the same value on both sides, you know these answers are correct. So what I'm going to do here is I'm going to erase this all. Okay, so what I'm going to do now is I'm going to see if these answers are correct. So I'll start off with 1 because that's easier to deal with. So I'm going to plug 1 in. I'm going to plug the 1 into this equation, and if I get the same answer on this side and on this side, I know 1 is correct. So since we got the same answer on both sides, we know that 1 is correct. Now, we can do it for number 2. We can prove that 1 over 2 is also correct. So, since I plugged in 1 over 2, 0.5, into both equations, and since we got the same answer on both sides, I know that 1 over 2 and 1 now, they're correct answers. So you can always check your answers. So if you're writing a test, or when I'm writing a test and if I have extra time, I can check my answer with this type of equation. So these are the answers.